You are about to discover something that will completely change the way you see the cosmos. Imagine for a moment that you were born completely deaf, never heard a single sound in your life. Then suddenly, at 30 years old, you gain the ability to hear. The entire world transforms, doesn't it? Well, that is exactly what happened to humanity on September 14th, 2015. On that day, for the first time in history, we managed to hear the universe in a completely new way. And what we heard was literally the sound of two black holes colliding more than 1 billion light-years away. But wait, before you think I'm talking about science fiction, let me explain how this is possible and why this discovery is one of the greatest achievements of modern science. You will understand how we managed to detect something so small that it is 10,000 times smaller than a proton. Today, you will discover the secrets of gravitational waves, this silent revolution that is rewriting everything we know about the universe. What exactly are gravitational waves? To understand this, we need to go back to the genius of Albert Einstein and his theory of general relativity. Einstein showed us that space and time form a kind of flexible fabric called spacetime. Imagine a well-stretched trampoline. If you place a bowling ball in the center, it will create a depression, right? That's exactly how gravity works. Massive objects curve spacetime, and this curvature is what we feel as gravity. But here comes the brilliant part. When very massive objects move in an accelerated way, they create ripples in this fabric of spacetime, like when you throw a stone into water. These ripples are gravitational waves, and they travel through the universe at the speed of light, carrying information about the most violent events in the cosmos. We're talking about collisions between black holes, supernova explosions, neutron stars spinning at mind-boggling speeds. The problem is that Einstein was pessimistic about our ability to detect them, and he had reason to doubt. The gravitational waves that reach us are incredibly weak. To give you an idea, when a gravitational wave passes through Earth, it stretches and compresses space so subtly that the variation would be smaller than the width of a hair strand across the distance to the nearest star. But scientists didn't give up. They had a secret weapon, a technology called laser interferometry. It works like this. You take a super powerful laser and split the beam in two perpendicular directions. Each beam travels through a tunnel several miles long until it hits a mirror and returns. When the two beams meet again, they can completely cancel each other out or create interference. When a gravitational wave passes through Earth, it stretches space in one direction and compresses it in the perpendicular direction. This means that one of the arms of the interferometer becomes slightly longer than the other for a fraction of a second. The laser beams arrive out of phase, and we detect this difference.
It sounds simple, but building a detector capable of measuring changes smaller than 1/10 of 1,000th the size of a proton is an engineering feat that borders on the impossible. Scientists had to create mirrors suspended by ultra-pure wires, completely evacuate the air from the tunnels to create a vacuum 1,000 times more perfect than that of space. The result is LIGO, the Laser Interferometer Gravitational Wave Observatory. Actually, there are two observatories, one in Washington State and another in Louisiana, separated by more than 1,900 miles. Why two? Because it's necessary to confirm that the signal really came from space. And then the miracle happened. On September 14th, 2015, at 4:51 in the morning, both detectors simultaneously captured a signal that made the scientists' hearts race. It was a chirp, a sound that started low and quickly became higher, lasting only 2/10 of a second. This sound was the signature of two black holes with 29 and 36 times the mass of our Sun, which spiraled around each other for millions of years until they finally collided. The event happened 1.3 billion years ago, when life on Earth was still microscopic. But here comes the fact that still leaves me speechless. In the last 20 milliseconds before the collision, these two black holes released more energy in the form of gravitational waves than all the stars in the observable universe combined were emitting in light at the same moment. 50 times more energy than all the light from hundreds of billions of galaxies. And when this energy finally reached Earth, after traveling for more than 1 billion years through space, it was so weak that it moved LIGO's 2.5-mile arms by a distance 1,000 times smaller than the width of a proton. This discovery was not just the confirmation of Einstein's century-old prediction. It was the birth of a completely new astronomy. For the first time, we could hear the universe beyond just seeing it. Since 2015, LIGO and its partners have already detected over 100 gravitational wave events. Most are collisions between black holes, but we have also captured the merger of neutron stars, objects so dense that a teaspoon would weigh as much as Mount Everest. One of these detections was particularly special. In August 2017, LIGO captured the gravitational waves from two neutron stars colliding. But this time, telescopes around the world also managed to see the event with visible light. It was the first time we witnessed a cosmic event with multiple senses. This discovery solved a decades-old mystery. Where do the heaviest elements in the universe come from? We discovered that events like this are cosmic factories that produce gold, platinum, uranium. The gold in your wedding ring was literally forged in the heart of a stellar collision billions of years ago. But the story is just beginning. In 2023, astronomers announced that they detected something called the gravitational wave background, a kind of constant cosmic hum. They did this using a brilliant technique. Instead of building gigantic detectors, they used the galaxy itself as a detector. They monitored 68 pulsars, stars that spin rapidly and emit beams of light like cosmic lighthouses. When gravitational waves pass between us and these pulsars, they cause tiny changes in the time the pulses take to arrive. It's as if we had finally developed the ability to hear all the whispered conversations of the universe happening simultaneously. And the future is even more exciting. There are plans for LISA, 3 satellites in space separated by 1.6 million miles, forming a gigantic triangular detector. With this, we will be able to hear collisions of supermassive black holes at the center of distant galaxies. Perhaps the most incredible discovery is yet to come, detecting gravitational waves from the Big Bang itself. Unlike light, which could only travel freely 380,000 years after the Big Bang, gravitational waves may have traveled since the first instance of creation. It would be like hearing the first sounds of the universe being born. Think about this. We, descendants of primates who only a few thousand years ago discovered fire, can now hear the whispers of space-time and detect collisions between the most extreme objects in the universe billions of light years away. We managed to build machines so sensitive that they can measure changes smaller than 1/10 of 1,000th the size of a proton. And we proved once again that Einstein was right. A century after he predicted gravitational waves, we managed to transform them into a tool to explore the deepest mysteries of the universe. Gravitational waves opened a completely new window to the cosmos. Through it, we are discovering that the universe is a much more dynamic and musical place than we ever imagined. Each black hole collision is like a note in a cosmic symphony that has been playing for billions of years, and we finally learned to hear the music. The universe has a voice,
and we finally learned to listen to it. And it is telling us incredible stories about dancing black holes, exploding stars, and maybe even about how it all began. If you were as fascinated by this journey through gravitational waves as I was, leave your like on the video to show me that it was worth sharing this incredible discovery with you. And subscribe to the channel, because we have many more mysteries of the universe to explore together. In the next video, we will talk about mysterious blue explosions that are brighter than supernovas and appear out of nowhere in space. Click here to discover this mystery that is rewriting everything we know about stellar explosions. Thank you for embarking on this cosmic journey with me, and until the next exploration of the mysteries of the universe.